Okay, Trig, this is day one of the second semester review packet. There are 40 questions on this review packet. I think there's 40. And so I'm going to try to get through the first like 12 or 13 today, something like that. And then we will continue on. We don't have a lot of kids in class on Wednesday because we have track, and I think golf is not gone on Wednesday. But anyway, so track takes out a lot, so we probably won't go through a review packet. That's why we're starting today. So let's just get right into it. I'm gonna work front to back in this packet. So number one, they talk about a one-to-one function. What the heck does it mean to be one-to-one? Okay, so one-to-one function means that it is a function and then its inverse is a function. Okay, so I'm going to say self equals function and inverse equals function. Okay, now how do you know if a graph itself is a function? You do the vertical line test. And how do you know if an inverse is a function? Well, inverted things are reflected across that line, y equals x. It's like something that's here is reflected over here, and you don't have to write that down, but you know that an inverse is a function whether if it passes the horizontal line test. So basically, or also, I guess, if something itself is a function, the x, I'm going to say no x's repeat. If you're talking about the inverse, for an inverse, the x's and y's are flipped around. So if in order for it to be a one-to-one function, no y's will repeat as well. Okay. And so that is how that kind of breaks down. So this function, how do we tell whether that thing's a one-to-one function? Well, let's think about just what like the parent function looks like. This is a positive 3, and it's to x to the 4th power. So we're looking at an x to the 4th power function, which should look like probably a w. Somehow, some way. And so, like, does it pass the vertical line test? Well, yeah, it will pass the vertical line test. So itself is a function, but no matter what, this is an x to the 4th power. So even if like it's flat in the middle and it doesn't have like an extra little bump in there, it's still gonna not pass the horizontal line test somewhere up above here. So this crosses out. So one-to-one, no, it's not a one-to-one function. It's a function, but its inverse is not a function, so it's not a one-to-one function. Okay. All right. Oh, by the way, write everything down in this review packet because you get to use them on your test. Your test will be 40 questions also. You get 5 freebies, so you don't have to answer 5 of them. Malia, what is going on, sister? Okay, hurry up and do what you need to do. Go. Okay. Find the inverse of this function. So there are 4 steps. Number 1, f of x gets switched and you rename him as y. A lot of people skip step number 1 because then y and x switch places with each other. Okay, so like if this becomes y, now my x and y switch places. So I have x equals the cubic root of y minus 4 and then plus 5. I kind of made my little bar really long, but whatever. Step number 3 is the hardest one, or the longest one, is solve for y. So now I have to unwind and I have to get that y by itself. Okay, so we're going to do like order of operations like in reverse. And so the first thing that I need to do is I need to subtract this 5 over. So I've got x minus 5 equals the cubic root of y minus 4. Okay, then the next thing, I'm going to undo this cubic root, so I'm going to cube it. I'm going to cube that thing. Okay, and you don't have to FOIL this thing 3 times. Like I really would not if I were you. You'll just leave it as x minus 5 cubed, but then x minus 5, that whole thing cubed, equals y minus 4, and then you add the 4 to the other side. So y is equal to x minus 5 cubed plus 4, and the last step is renaming the y, and you're changing it back, but you're calling it f inverse of x. So final answer, f inverse of x, and it looks like f to the negative 1 power, x minus 5 cubed plus 4, and that's what he will look like. Okay, that is your inverted function. Okay, and it's the same 4 steps every time, regardless of what the function looks like. So if it's a square root, or if it's a linear function, or whatever, same 4 steps. Okay, all All right, transformations. All right, should we talk transformations here? Let's do it. Over here off to the side. 2 to the x power, that's my parent function. Here are some things that we could do to that function. If, let's say, I have, I'm going to go 2 to the x plus 4, 2 to the x minus 3, 2 to the x plus 6, 2 to the x minus 7. Here are all different things that could happen. Let's say 2 to the 3x power, 2 to the 1/2 x power. Let's go 4 times 2 to the x. I'll pause so that you can write all this stuff down. 8 times 2 to the x, and then negative 2 to the x, and 2 to the negative x. Okay, that was a lot of things. So this is all stuff. And we'll write down what is happening to that. Okay, now if you don't need this little cheat sheet off to the side, you don't have to. This is my parent function. We'll just write down what each step is, and then you can just go from there. But if you don't need this cheat sheet, you don't necessarily have to write it down. Okay, if you need to pause to write all that stuff down, go for it. I'm just going to start going through to save time. So this plus 4 is moving it up 4. So this is an exponential function, by the way, so he would look like something like this, right? And it's just moving that up 4. So now, like, we're up higher in the air, whatever, okay? Next one, minus 3 is down 3, okay? This plus 6 and minus 7, they're, like, up in the exponent, and so it's kind of like it's in parentheses, and so it's the opposite of what you think. So plus actually means to the left 6, minus actually means to the right 7. Okay, so that's how that works. Some of these rules should be familiar to you, I hope. If they're not, I don't know. But they should seem a little familiar too. Now these ones are going to be a little bit harder. This 3 is up in the exponent, and that's going to be a horizontal something, right? It's either a stretch or a compression. And kind of like the way that it was here, it's the opposite of what you think. So this, since it's a whole number, is actually going to be a compression by, and I have to use the reciprocal. So it's a horizontal compression by 1/3. Okay, opposite thing here, we have a horizontal stretch by, the reciprocal of 1/2 is 2. So it's a horizontal stretch by 2. Okay, this next one is a vertical stretch by, oh shoot, I should have put 1/8 here, not 8. Fix that. Make that 1/8 instead. Vertical stretch by 4, and this is a vertical compression by 1/8. Those are just the way that they are. You don't have to do any funny reciprocal fancy business, nothing. Okay, so vertical stretch by 4, vertical compression by 1/8. Okay, and then the last two, this is going to be over the x-axis since it's down here in front, and then this one is over the y-axis. So it's like a reflection, if you want to use the proper verbiage, I guess, whatever. Over X, over Y, okay? If that was too fast, take some time, write that down, pause it if you need to, but there is that. All right, now we got to use all those rules to figure out what is going on here. 2 to the x power is my parent function, and what do we got going on here? We've got 2 to the x power. So I have 1, 2, 3 things that are happening, okay? 1, 2, 3, and I put them in order. Okay, so if I were to put a number in for x, would I apply the 4, would I apply the 8, or would I apply the negative? Okay, I'm going to, if there's a number in here for x, I'm going to apply the 4 first. So I got to figure out what the 4 is doing. Then I would apply the negative. Well, I would take it to this, like 2 to that power first, but that's already a part of the parent function, right? So the negative comes next, okay, we'll deal with him, and then the plus 8 goes last, okay? Now, this 4, because he's in the exponent, is a horizontal something, and I have to use the reciprocal, so 1/4, so that's a horizontal compression because it's by 1/4, okay? The negative is going to be over x, and the 8 is going to be up 8, so that's kind of how that boiled down, okay? All right, we're going to get going a little faster. Here we go. Evaluate. These are going to go fast. Logs, okay? Evaluate this thing, okay? When I'm in log world, and I am stuck. My brain can't think in log world. So what I have to do is I have to switch it to an exponential function because that's the way that my brain thinks. But I have to have pieces. So I'm going to say equal to x over here. So I have the 3 pieces. And then I just do the flippity-do thing where I change them to an exponential function. So my base is still 5. This guy stays in the same spot. But then these two switch. It's kind of like that circle pattern. So 5 to the x power equals 1 over 25. Now, I have to figure out what x is. That's what I'm solving for. I know that if I'm going from 5 to 25, that power is going to be 2. Like 5 squared is 25. But how do I get it to be 1 over 25? It's going to be a negative 2. So x equals negative 2. Negative powers change into being a fraction, right? Okay, so x equals negative 2. All right, next 5. Okay, this is another exponential function, all right? And these, I have 2 exponential functions equal to each other, and I'm trying to solve for x. So my bases are 2 and 8, okay? And what I'm trying to do is, if at all possible, I would love for it to be possible that I could make those the same base. And like 2 is already a small number, so I don't think I can do anything with 2. So that's just going to stay 2 to the 5x power. But I know that 8 is equivalent to 2 cubed, right? Like I just rewriting this 8 as 2 cubed. Now don't forget that the 5 is still there. I'm just taking and I'm rewriting it, right? And now that I have the same bases, I can just cancel those, and I have 5x over here is equal to 3 times 5 is 15. And then I divide by 5, and x is 3. And that's all. So just try to change and make them the same base. Sometimes you might end up changing both sides. So like if this was a 4 and this was an 8, I would write this as 2 squared, and this would be 2 cubed. Like I'm just reducing those down into, and then you multiply by whatever your exponents were, right? So just be careful of that. But you're just rewriting them to be the same form so that you can cancel them, okay? That was 5. Translate into equivalent log statement. So now we are going from exponential world to log world. All right, so we have a log with a base of something equals something, right? I have to figure out what my 3 pieces are. So first number stays in the same spot. This becomes a 3, and then the second 2 numbers switch. And actually this 2k, that's kind of confusing. The 2k is 1 unit together, right? So 3 log base 3 of y equals 2k. Okay, and this is kind of a little bit confusing. All the log, the y, and the 2k, y2k, funny. Log y and 2k should all be kind of on the same level with each other, and the 3 should be the only one that is down, like as the subscript. Okay, otherwise all of them should all be on the same page. And that's what it looks like as a log function. Okay, you don't have to solve for anything because there's nothing really to solve for, but they just want you to write it in a log function, okay? All right, 7. We need an equation, and this is compounded quarterly. So I need the equation for compound interest. I'll write that down. Compound interest, and here it is. It is A equals P. I hope I get this right. 1 plus r over n to the nt power, okay? If you need these written in here, this is the after amount. If you don't need to write these in, don't write them in, because like you don't need that extra stuff on your paper. This is the principal, okay? R is the rate, T is the time, and N is the number of times you are compounding, okay? So in this case, quarterly, that means N is 4, okay? If you want to write them down, you should know these. I'm not going to write them down for you. Like monthly would be N is 12. Daily would be N equals 365. I don't know what else. That's mainly it. Those 3. They might do annually, then N would be 1. Whatever, okay? If you invest $5,000, that is P. For 7 years, that is T. At 6% annual interest, that is R, but be careful because they want you to put it in the equation as 0.06. How much will your investment grow to be if it is, so we're just finding the after amount. That's easy. After equals 5,000 times 1 plus R is 0.06, and I'm going to divide by 4, which is N, to the 4 times 7 power. All right, if you want to make life easier, because I don't trust my calculator because I have a dumb calculator, I'm going to, this is going to be 28, okay? But 0.06 divided by 4, if you do this in pieces, because I don't trust my calculator, 0.06 divided by 4, and then add 1, this is 1.015, okay? Now I take that to the, 28th power, and then I take that times 5,000. And my investment is now 7,586. And since we're dealing with money, 2 decimal places, 11 cents. That is what my investment has grown to be in 7 years. That's not bad. Okay, but you'll never get a 6% annual interest anywhere, probably. Okay, that is compound interest. That's the formula that you need. Now, the next one is compounded continuously. And continuous compounding, you should know this, is PERT. Okay, do I need to fill in the variables? I'm not gonna. If you want to write in rate, time, principal, after, whatever. How long? Circle how long. Circle the word how long. That means we are solving for T. All right, will it take to double an investment of $3,000? Or 300. That means my principal is 300. Okay, 300. E to the rate is 5%, so 0.05, and we're solving for T. What's the after amount? Think about it. Double an investment. So this is 600. Okay, now this is where I have to use my logs and exponential functions and stuff to solve for T. Okay, so let's do some algebra first. I'm going to first divide by 300 because I can do that. And this will end up being 2. 2 equals e to the 0.05t. And now I have to figure out how I'm going to get rid of this e so I can get to the t power, right? So I'm going to put an ln in front of both sides because it cancels on the right. And so I've got ln, I'm going to write this up here at the top, boop, 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 right there, okay? I've got ln of 2 equals, and the ln and e canceled, and then the 0.05t come down, okay? And then after I do ln of 2, you need to close your parentheses off and then divide by 0.05 to get t. Or I would just do ln2 enter, divide by 0.05 enter, okay? And let's see what I get. I got time as being 13.86 years. Okay, 13.86 years. All right. It doesn't say what to round to. I would do at least 1 or 2 decimal places on that. I mean, 18.6 or 13.8 is not going to be very different than 13.86 years. So, or I guess it would be 13.9. So the second decimal is not going to do a whole lot. I mean, maybe a little bit. I don't know. Anyway, at least one decimal place. Okay. All right. The next equation that you need to write down is for half-life. Half-life. Okay, and I don't have the half-life formula in front of me, so bear with me. B times 0.5, or 1/2, to the T over K power. I gotta think about that for a second. Yes, T over K power. K is the half-life. I don't know why they represent it as K. You can put it as H if you want to. We'll just say H. Half-life. Okay, so, and the half-life will be determined by whatever the half-life of that element is. Like they will tell you the half-life of radium. Half-life of radium 88 is this many years. That means it takes that many years for that element to split in half. Every element has a different half-life, whatever, okay? So that's gonna go in for my H. I'm gonna label that as H, okay? How long? Again, we're doing the how long thing, so that means we're solving for T. Will it take for 10 grams to decay to be 1 gram? So my after amount is 1. My before amount is 10. Whoop. Times 0.5 to the T over 1590. Woo. Okay, now, hold on. Un momento, por favor. We're starting with 10. And if it splits in half, it becomes 5. And if it splits in half, it becomes 2.5. And if it splits in half, it becomes 1.25. And if it splits in half, it becomes, whatever, 0.75? I don't know. 0.625. That's what it is, right? So we are now right about here. So it has split in half 1, 2, 3 times at least. So the number of years that has elapsed has to be 3 times this much, right? Like think about what a logical answer would be. I'm going from 10 decaying to 1. It's split in half quite a few times, 3 times, 3 plus times, right? So I've got to figure out what that is. All right. First thing I'm going to do, algebra, divide by 10. Okay. Next thing I'm going to do, 1 divided by 10 is 0.1. equals 0.5 to the t over 1590 power. Okay, now I'm going to do an ln in front of both sides just like we just got done doing, except it doesn't cancel on one of the sides because it's not an e. But what that allows me to do is take this guy and move him down in front. So I have ln, I'm going to use parentheses, of 0.1 equals t over 1590 times ln of 0.5. Now what I'm going to do is I'm going to take this and I'm going to divide him over. So I'm going to divide by ln of 0.5, divide by ln of 0.5. Okay, I'm not sure if my calculator will do this. ln of 0.1 divided by ln of 0.5 is, I have my dumb phone calculator, so let's see, 0.1 ln divided by 0.5 ln equals, maybe 3 point, yeah, that should be right, 3.32. That's how many times it has split in half, right? It's 3 and some change, right? Equals t over 1590. So then I'm just going to multiply by 1590 times 1590, and that gives me 5,281.9 years, we'll just say. Okay, something of that nature, whatever. Okay, good. Use some logic as you're doing this. All right, let me keep going. Solve this by using the properties of logs. Okay, my brain doesn't think in log world, so I do all the algebra I can, and then I switch it to an exponential function. And is there any algebra I can do first? I cannot divide this 4 over because he is stuck inside of there, so I'm just going to switch to an exponential function. I do not have a base here, which means the base is 10. And this becomes 10 to the second power equals 4x, right? 10 to the second power was 100, and then I'm going to solve for x by dividing by 4, and that is 25. That's all. If you want to type that into your calculator, you totally can. Just take log of 4 times 25, and it should come out to be 2, right? If you can just check real quick on your calculator thinks in log base 10 already, so you're good to go. All right. Number 11, we've already solved one like this. We did the harder version, but this is already set up, ready to go. E to that power equals 7. If I want to get rid of an e, I'd do an ln to each side, and that just cancels. So I've got 3x equals ln 7, and then I'm going to take that and divide by 3. So whatever ln of 7 is, that whole thing divided by 3, and I'm going to get like 0.6486. I'm going to go 4 decimal places on those, okay? Anytime you're doing an ln or whatever and it's not a story problem that has like change and stuff, go ahead and give me like 3 or 4 decimal places, okay? That is 11. Last one, 12. We'll stop after this one because it's kind of a nice breaking point. Okay, they want us to express this as a single log. We are not solving for anything because there is no equal sign. I just have this guy here, and then I have this guy here, and the only thing that are separating them is this minus, but minus in log world means divide. Okay, before I divide them, I got to get rid of this 2, and I'm going to put him to the back, so this is x minus 3, that whole thing squared. Okay, and when I put him as one log, it's going to just be ln. Like this ln comes to like one little thing right here, okay? And then I've got a bunch of stuff. So ln of those 2 things combined. All right, and I'm dividing. So I'm taking this guy and I'm dividing by this guy. So x minus 3 squared over 4x. This is how I express him as a single log. Not solving for anything. That's it. You just write him as one piece, okay? All right, we will stop there. I know that's only 12 problems, but I mean, some of this other stuff I'd rather just do with you in class, especially when we get into like the real hard trig stuff down here. So there you go. Okay,